What if the biggest revolution in rallying wasn't four-wheel drive? What if it was where the engine sat? For decades, rally racing followed a simple formula. Take a production car. Keep the engine where the manufacturer put it, up front, then modify everything around it. Suspension, brakes, tires, power. It worked until the cars became too fast for the formula. Because there was a problem hiding under the hood. Wait. A heavy engine sitting over the front axle doesn't just add mass. It changes the way the entire car wants to move. When the driver turns into a corner, that mass resists rotation. The nose doesn't want to turn. It wants to keep going straight. And the faster the car became, the more obvious the problem became. Drivers compensated the only way they could. They threw the car into aggressive slides. They used weight transfer. They used throttle. They used every technique they had to force the nose around. It looked spectacular. But spectacular isn't necessarily fast. Every unnecessary slide costs time. A fraction here, another fraction there, and over hundreds of corners. Those fractions become minutes. Engineers try to fix it. Different springs, different dampers, different suspension geometry, different setups. But eventually they faced an uncomfortable truth. You can't tune physics out of the car. If the biggest mass is sitting at the front will always have to deal with it. And that was when rally engineering began moving towards something radically different. Put the engine in the middle. Lancia's answer was the 037. Instead of taking an ordinary front-engine road car and transforming it into a rally machine, Lancia designed the car around its competition purpose from the beginning. The engine was mounted between the axles, low, central, and close to the car's center of rotation. The difference was enormous. Instead of dragging a heavy nose through a corner, the 037 could rotate far more naturally. The car responded quickly to steering input. It could change direction with remarkable precision. And on tarmac, that agility became a genuine weapon. Because Audi had the Quattro, four-wheel drive, more traction, more power, and a technological advantage that looked almost impossible to overcome. Yet on the right surface, the lightweight mid-engine Lancia could fight back. And sometimes, it could humiliate the Audi. That created one of the great lessons of the era. More driven wheels don't automatically make a car faster. Because traction is only one part of the equation. You also have to turn, and brake, and change direction, and control the car once it begins to rotate. Where the weight sits can matter just as much as where the power goes. But then came the darker side of the mid-engine revolution. Because making a car rotate more easily comes with a price. A mid-engine layout concentrates more of the car's mass near its center. That makes the car incredibly responsive. It can change direction quickly. It can feel almost alive underneath the driver. But once the car passes the limit of adhesion, that same responsiveness can become terrifying. A front-heavy car has a certain natural resistance to rotation. It can be slow. It can understeer. But that heavy nose can also give the driver a little warning. A mid-engine car can be different. Once the rear steps out far enough, the car can rotate extremely quickly. And in Group B, there was an enormous amount of power behind that rotation. These weren't ordinary rally cars anymore. They were becoming lightweight, turbocharged, mid-engine missiles. The cars could respond faster than the driver's instincts could sometimes keep up. And when the tires finally lost grip, there wasn't always enough time to save it. That was the terrifying paradox. The same physics that made these cars brilliant could also make them unforgiving. The pursuit of performance was moving faster than the safety systems surrounding it. Power increased, speed increased, grip increased, and the consequences of getting it wrong increased with them. Eventually, the human limit became part of the engineering equation, and Group B couldn't outrun it forever. The era ended, but the idea didn't. Because engineers had learned something that would never be forgotten. Performance isn't just horsepower. It isn't just traction. It isn't just top speed. It's mass. Where that mass sits. And how quickly you can make it change direction. That philosophy survived Group B, and it still exists in modern rally engineering. Today's Rally 1 cars use hybrid systems, batteries, and electric motors that must be packaged carefully around the chassis. The goal is still familiar. Keep the mass controlled. Keep the car responsive. For decades after the 037, the engineering question hasn't really changed. Where should the weight go? Because once rally cars stopped being modified road cars, they became something else. Purpose-built machines, engineered around the physics of rotation.